going to talk about all of these. The whole test is dealing with exponential functions. Okay? That is y equals a times b to the power of x. That b value is your factor ratio. That a value is your initial value, or y-intercept, when x is equal to 0. Now, there's a couple of very important concepts with exponential functions. That b value, that base with the x, must be greater than 1, or the b must be less than 1. It cannot be equal to 1. If it's equal to 1, it doesn't work. It basically ends up being a linear equation. Okay? So it has to be greater than 1. So 1.1, 1.01, okay? 0.99, okay? So if you have a b value of 0.99, don't round it up to 1. That won't work. You need to keep it as 0.99, okay? Now, let's talk about how we get that. So when we talk about growth, where it's greater than 1, okay, we still have our a value, okay? So this a value is the same here, here, and here, okay? The b value, where begin, is this whole thing, okay? Decay is 1 minus. Growth is 1 plus. R rate, or 1 minus R rate. Now, when you are converting to that rate, in order to get that value, you must take that rate and divide it by 100. You want it as a decimal. Does that make sense? Now, we're going to go into a little bit more clarification in that in just a moment. I want to just go over some of the base concepts from graphs and tables for A, B, and finding our ratios. So we're going to go ahead and skip the first part of the page and go to the second back page, okay? Oh, one more thing, sorry. One more thing I'm going to comment on your graphs. So your decay, your graph should look like this. Growth, your graph is going to look like this. So think growth, you're going uphill. You want to think like a roller coaster, right? When you think of a roller coaster, you're going up. That's increasing, right? When you're going up, and then you're going to go over that little hump at the end, at the top, and then you're going to go down, right? And you're going to go down what? Really, really fast. So that part where you're going up on a roller coaster, that represents an exponential function. That part where you're going down really, really fast, that represents decay on an exponential function. Does that make sense? Okay, so now understanding that concept, looking at this first graph, what do you think that is? Do you think that's growth, or do you think that's decay? You think this is growth? Think about where your car is starting here. Your car is starting here. So this is going to be decay. Does that make sense? This is going to be your car is starting here because you're thinking about where you're starting with the x values. Your x values are always left to right. So this start here, here, here. You're going this way. Does that make sense? So this is what? Growth. This is growth. Good. And this one is growth. All right. Now let's talk about 11, 9 through 12. When we're identifying growth or decay, we are looking specifically at our b value. So our b value is with the exponent. So that means, what's my b value here? 1.07. So 1.07 is greater than 1, so that means, is that decay or growth? Growth. All right. Number 10, 0.89. Is that decay or is that growth? Good. 0.5, that's less than 1. So is that growth or decay? That is decay. Perfect. 4 is greater than 1. So that means what? Growth. See how easy that is? So like now thinking about that picture like mentally, you know that your graph for that is going to look like that. You know that the graph for this is going to look like that. You know the graph for this is going to look like that. The graph for this is going to look like that. Does that make sense? Now, let's talk about how I can break up that B value in terms of where you have the 1 involved. So you know that the growth would be 1 plus the rate. Now, the 1 is easy because we know that's 1.07, so we know we added the decimal of 0.07. Now, then it says, what is the percentage rate? To convert that percentage rate to, or that decimal, 0.07, the opposite of division is multiplication. So if I divided by 100 to get that decimal, I'm going to multiply by 100 to get that percentage. So 0.07 times 100 is 7. All you got to remember is move the decimal over to the right 2 places to get the percentage and to the left 2 places to get the decimal. Okay? Now, it's a percent. I know my percent looked a little wonky. I'm sorry. I'll clean it up. There. Does that look better? Okay. Okay. Now, here's the tricky part. The tricky part is with decay because your rate is not 89%. So you are not doing 1 minus 0.89. You are doing 1 minus a number, and that is actually 11 to get that value. So, and you can find that by doing 1 minus 0.89 and find what that decimal value is. And then say, okay, then your rate is at 0.11. It's really important that you understand that because there is a test question that you have to answer that with on the test. Okay? So then that lets me know that that is 11%. Does that make sense? Any questions on that? Okay. Okay, so I did 1 minus 0.89. 1 minus 0.89 gives me 0.11. That lets me know what I subtracted to get the 0.89. Here, this is decay, so that's 1 minus. This is easy, it's 50%, so that's just 1 minus 50%. So we know this is 50%. Yeah, my percentage symbols are awful. My handwriting's still better than a lot of y'all's. Okay, this is growth, so we know this is 1 plus. And 1 plus, remember, so to get that actual what we subtracted from 1 originally, to get that B value, I'm going to subtract 0.89 from 1. That gives me 0.11. So to get that 0.89, I had to subtract 0.11 from 1. So think, 1 minus 0.5 gives me 0.5. So 1 minus 0.5 gives me 0.5. So that one was 50% is 50%, right? Now, this is 3, not 0.3, 3. Because this is tricky. Because what's 3 times 100? This is actually has a 300% rate. And yes. Mm-hmm. 16. So this is really easy. Okay. 13 through 16. I'm going to look at my Y values. Are the values increasing or decreasing? They're decreasing. So that is decay. Number 14. What are my Y values doing? Are they getting bigger or are they getting smaller? They're getting bigger, so they are growth. 1 is larger than 1/8. On number 15, that's growth. Number 16, we're decreasing. 1 is smaller than 16. Okay, now let's.
But if that has increasing.
It won't be an exponential function. If we have increasing and decreasing, then we have another type of function. If we have increasing and decreasing, most likely that's going to be a quadratic. We're not going to be dealing with quadratics until after Christmas, after winter break. So just think increasing, decreasing. Okay, that's all you got to think about this time. Now let's talk about finding our b value. There are two ways to go about this. One of the ways you're going to need to know for your test, you need to take, so think, this is term 1, this is term 2, term 3, term 4. I'm using T to represent term, right? Does that make sense? Okay, so I need to take any term if I go to term 16, okay? If I start at term 16 and I'm looking specifically at the y values, we're finding our b value. Your b value is the factor ratio. That means what am I multiplying 128 by to get 64? Okay. In order to do that, I'm going to take any of these terms. So I can start at 16. And then I'm going to take 16 and I'm going to divide it by the term prior. The term prior is 32. So my ratio is going to be 16 divided by 32. I'm going to go to Desmos and do 16 divided by 32. Gives me not 2, be careful, 0.5. That's a double check because you want to think. You know that this function is decay. If you put 2, 2 is going to give you a growth function, not a decaying function, because that would give your b value as greater than 1. So make sure you want to not do 32 divided by 16. You're doing 16 divided by 32. Does that make sense? You're doing 32. If you do 32 on top, you're going to divide 32 by 64, which is going to give you the same factor as 1/2. You're going to do 64 divided by 128. You're halving 128. You're halving 64. You're halving 32. That gives you 16. Does that make sense? Okay. Now, it gets a little tricky with number 14 because we have fractions. So my recommendation for you is if you have fractions, we're going to go ahead and open up Desmos. And we're going to open up our table and we're going to enter our table list of values. And I'm going to put them exactly as they are. How do I do what? Put plus and then table. So so if they're consecutive and you hit enter, it will automatically put it in there. So it automatically knows that you're consecutive. Now, I'm putting 1 and then the /4, 1/2, and then 1. Now, I'm going to hit this button, add regression. You want to change this. This is not a linear function. This is a exponential function. So I'm going to change it to exponential. Now, I'm zooming in so that I can highlight all I care about. I'm going to zoom out now. We want the b value, right? So look, our b value is with the exponent. That b value is what? 2. So that means this value here is 2. Do y'all see how I did that? Let me go back. So I created my table, created my exponential regression line. I zoomed in on the values. This 0.000610352, that is that 1 divided by 8. That is that number as an estimate. Okay? Does that make sense? Now, you could also look like 1 divided by 1/2. When you're dividing a number by a fraction, you have to flip and multiply. So that would be 1 times 2 over 1, which is 2. Now, again, if you can't remember that, don't stress that out. Just put the table in and calculate it, okay? Now, number 15, that's easy. I can do 216 divided by 36, 36 divided by 6, or 6 divided by 1, which means our B value is 6. Our B value is greater than 1. It's growth. We're good. We're going to do the same thing with number 16. So 1 divided by 4, that is 1/4. 4 divided by 16, that's 1/4. 1 divided by 4, 1/4. 1/4 divided by 1 is 1/4. Does that make sense? Zoom in? You can't see that close? Like, come on. That's a 6. 6 divided by 1. 16. That is a 16, yes. We're doing 4, this term divided by this term. Clearly. You got it? Now we're looking at remember the thing about, okay, so just to mention this and talk about the things here. On the top half over here, when we're looking at the B value, our B value is y equals a b to the x. So that means when we're looking at the B value, we're looking at the base with the exponent. So those are all our y. That's not the y-intercept. That's that point when x is 1 typically. Okay? It's the ratio. Now, here we're looking at the a value. We want the a value in terms of the function. So that means y equals a b to the x. So we want that initial value. That initial value is where we cross the y-axis. So that is 1. Here, it is 500. Here, x is 0. That means our b is 9. Not our b, our a, sorry. I was mentally mixing it up with linear functions. Okay, so here on this part, so 21 through 24. So we're looking for our B value. No, we're looking for our A value. So that is 5, 100, 3, 10. So that means 5, 100, 3, and 10. If there is no value in front, and it's just say something like y equals 3 to the x, that a value is 1. If there's no number in front of the 3 with the exponent. No, because you're multiplying your coefficient. If x is 0, that would become 3 would become 1, because anything to the 0 power is 1. Okay? Yes. No, that's 1 times 3. Now, the second half of this, we're doing just like we did above. So this is decay. So we know that would be 1 minus 0.75 is 0.25. So that is 25%. This is growth. So that's 1 plus 0.04. That is 4%. This is growth. That's 6. So that would be 600%. This would be minus 0.05. So that would be 5%.